Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayatul Ain binti Cik Azman. Today, we are going to present about our project, which is jaw guard for broken jawbone patient. So, our supervisor is Dr. Muhammad Ashraf bin Ahmad, and my others member is Ahmad Imran bin Jaafar and Chakaisin. For the brainstorm, we use a flat sensor to detect the angle. If the band is exceed the limit angle, the vibration motor will notice the patient with a vibration. Specific requirement. This product will help patient in treatment, which is it will reduce the cost of treatment. And the patient will feel more comfortable when wearing this product because this product only need to wear around their face. Sketches. For the sketch number 1, the advantage of this design is portable, and the disadvantage for the design is not environmental friendly when the bezel is triggered, and it will cause a noise. This is the 360 view angle for design 1. Sketch number 2. The advantage of this design is easy to wear and support the functional tasks, but the disadvantage of this design is the motor is heavy in weight. Sketch number 3. The advantage of this design is the thread will pulling the belt band when it getting triggered to control the jaw angle, and the disadvantage of this design, the motor is heavy in weight. This is a 360 view angle for design number 3. Sketch number 4. The advantage for this design is it is a portable and environment friendly, and the disadvantage for this design is the vibration motor will only alert when it get triggered. This is 360 view angle for design 4. Sketch number 5. The advantage for this design is the LED will display and show the warning or normal sign depend on the angle of the jawline, whether it reach its limits or else. And the disadvantage of this design is it is not easy to bring anywhere. So this is actually how to wear this product. Patient need to wear it around their head and make sure they wear it properly so that the flat sensor can detect the angle when they open their mouth. Next is decision metric table. So here we have 5 requirement and 7 criteria. Requirement number 1 is weight, number 2 is low energy consumption, number 3 is low noise, number 4 is closed loop, and number 5 is easy mobilize. For the criteria, we have safety, environment friendly, robustness, elegance, aesthetic, cost-effective, and easy maintenance. Based on the decision matrix table, solution 4 has the highest mark compared to the other solution. As conclusion, we choose cache number 4. This is because based on the decision matrix table, it has the highest mark and it is more suitable to use. This is the demo from the hardware that we already designed. This is a simulation result from the hardware. As we can see, when the bending degree is less than 100, it will show a normal, and if the bending degree is exceed 100 degree, it will show warning.
Good day to the panel, I'm Kai-Sing. So for the calculation of our design, we are using same theory also. To calculate the output voltage of the circuit, we are using the input source voltage with the VCC multiplied with the flat sensor resistance over the constant resistance plus flat sensor resistance. And to calculate the flat sensor resistance, we are using the constant resistance multiply the input voltage over the output voltage and minus the constant resistance. And this is the example for the calculation. For R1 is the constant resistance, we are using 220 ohm. For RV1 is the flat sensor resistance, it's 450 ohm, as the value from the sensor is about 400 to 700. And the output voltage we get is 3.36 volt, and for the flat sensor resistance we get is 107.38 ohm. And for the component integrations, we are using the belt band attached with the component with the flat sensor and the vibration motor to make up our product. And here is the mechanical drawing how our product look in the actual. We are using the Autodesk Inventor to draw out the product. And this one is the simulation video to show the timing and sequence of how the product work in actual work. So as here you can see that when the flat sensor is bending upon the alert angles, it will trigger the vibration motor to alert the user. And next one is the circuit drawing. And for the design one, we are using the temperature sensor to replace the flat sensor. As we know, the flat sensor cannot run in analog in the simulation. And for circuit 2, we are using the potentiometer to replace the flat sensor. So this is the simulation result for design 1. We are using the temperature sensor. And with making some improvement in the bending degree. We'll set the alert degree at 20 degree as the maximum jaw angle for the normal person is 26 degree. So we set it at 20 degree. So you can see that if the angle is exceed 20 degree, the LED will light up, and if the angle is below 20 degree, the LED will turn off. So this is the simulation 2 result for the design 2. We are using the potentiometer. So you also send that if the angle is exceed 20 degree, it will trigger the vibration motor to vibrate. If the angle is below 20 degree, the vibration motor will not vibrate, which means that the LED will not light up. And this is the flowchart for the simulation 1. By using the temperature sensor. At start, the Arduino will read the value from the sensor, and the input value need to change from analog to digital by divide by 100, 1024 and multiply with 5000 with the 5 volt, and the value need to divide by 10 as the value is increased for every 10 millivolt. So if the value is exceed 20 degree, it will trigger the vibration motor to vibrate. If the angle is below 20 degree, the vibration motor will not be triggered. So this is the flowchart for simulation 2. We are using the potentiometer. At start there, we need to declare the variable and assign the pin number to the variable. The port pin equal to A1 is the input pin from the potentiometer, and we need to declare a variable with the port value equal to 0 to store inside the potentiometer. And next one, you need to declare the pin as the input or output pin, and initialize the serial monitor, which the serial begin 9600, and it means that the bounce rate for the to indicate that how fast the information is transferred to the communication channel. So the value is read by the pin. If the value is exceed 20 degree, it will trigger the vibration motor to vibrate. And if the value is below 20 degree, the vibration motor will not be triggered. So this is the pseudocode for simulation 1. It's been explained in the flowchart 1 just now. And this is the simulation pseudocode for simulation 2 for flowchart 2 just now also. So this is the coding for hardware simulation that show how the product is worked in the demo video just now. And the coding is almost the same with the software simulation, just in case we are adding the coding for the flex sensor. And as we know the resistance output from the flex sensor is in resistance, we need to change it to the angle. So we are using the formula with the flex pin minus 400 and divide by 2, as the sensor value is about 400 to 700. So by using the formula, it can help us to change the value from 0 degree to 180 degree.
Hello, Assalamualaikum. So this is the influence of our product to environment and sustainability. First, is portable compared to Sketch 2 and 3 that has a heavy motor in weight that prevent to bring it anywhere. Second, it is easy to wear and use. Third, it is environment friendly as it did not cause injuries when used it and also does not disturb the public environment. And also lastly, it has high endurance even though it has used multiple times. Next, this is our product safety element. First, it is easy to wear and to operate compared to Sketch 1, 2, 3 and 5. Second, the uses of rubber for the product that prevent from injuries when you use it and also has high endurance. And lastly, the vibration motor that alert and keep the user's jaw in safe condition. So this is our Gantt chart. It shows each of our tasks from week 1 to week 14. It helps us a lot as we can finish our each task on time. Next are the cost management. First, bill of materials, easy maintenance as the material used are high endurance and can use it for long term that brings to reduction in using money for maintenance. Lastly, the material used are cheap and affordable compared to product 1, 2, 3 and 5. So this is some of materials or equipment that we use in our project. First, there are Arduino Uno, flex sensor, diode and transistor. We also use 22 kilo ohm resistor, blue cable and lastly red cable.